Hello. In this brief video, we will see how to calculate future value, present value, rate of interest, and time for compound interest problems. My goal here is to show you how to write formulas in Excel. I believe that once you know how to write a formula and you know what is going on behind the scenes, it is okay to use the inbuilt functions in Excel. Let's start with our first example. You have deposited $1,000 for 3 years into any instrument. You can think about a certificate of deposit, for example. Your bank offers you 4.25% interest. How much money will you have in your account after 3 years? Let's write out all our information using the symbols or the notations for each. You know that the basic compound interest formula is written as future value equals present value times 1 plus the rate of interest to an exponent of time. Some of you may have seen that as amount equals principal times 1 plus rate to an exponent of time. Present value is what you have now. You have deposited $1,000, so that's the present value of your deposit. The rate of interest that you will earn is 4.25%. 4.25% is 0.0425. You are letting your money sit there for 3 years. Now, unless otherwise mentioned, all problems involving compound interest will require you to assume that you do not make any changes to your account. You do not withdraw. You do not make additional deposits. Let's write the future value formula. Future value equals, here is the present value, times 1 plus, here is the rate of interest, close parenthesis, to an exponent of time. Let's display a couple more decimal places. We know this may not be an even number. Actually, it is. So if you deposit $1,000 at 4.25 interest for 3 years, you will have $1,133 in your account. Let's move on to example 2. Very often in the real world, you will face situations where you have a goal and a financial goal, and you will have to figure out what you need to do today in order to achieve that goal. In example 2, we have the following situation. You need $2,000 for a vacation 2 years from now, so you're planning ahead. Your bank offers you 3.5% interest. What you will need to determine is how much should you deposit today in order to have the $2,000 for your vacation 2 years from now. So in this problem, $2,000 is what you need 2 years from now. That's a future value. So future value is $2,000. Your bank offers you a 3.5% interest. 3.5% is 0.035. You have 2 years in hand, so t equals 2. This time you have to calculate present value. Rewriting this future value formula in terms of present value, you can see we need to divide both sides by 1 plus r to the t. So the present value formula reads present value equals future value over 1 plus r to the t. This is called discounting. We are going to discount this $2,000 that's going to come to us 2 years from now. We are going to discount it at 3.5% to figure out its value today. The first formula here was compounding. We compounded into the future. Now we will discount to the present. By this time you may have figured how to write the formula. Let's go ahead and write present value equals, here is our future value divided by, open parenthesis, 1 plus, here is the rate, to an exponent of time is 2 years. So you need to deposit $1,867.02 today in order to achieve your goal. Now, you might want to round it off to $1,867, but just as food for thought, I want you to also understand that if you deposit $1,867, you will have a little less than $2,000. So let's do a couple of things before we move forward. When you first start working out these problems, you may want to keep going back and forth to check your answer, make sure you see how the concepts hang together. So here is the first thing I'm going to do. I'm going to see whether this answer is really correct. In other words, if I deposit $1,867.02 today, will I have $2,000 at the end of 2 years? Let's work it out. In that case, I would be working out future value. So I would say this is the amount I'm depositing now times 1 plus the rate of interest that I will receive to an exponent of the number of years I'm letting my money sit there. So yes, I have the $2,000. What if I have decided to round it down to $1,867? Let's see how much of a shortfall I would have. In that case, I cannot link to this value, because if I link it to here, Excel will pick up the 2 cents. Let's write this as equals $1,867 times 1 plus r to an exponent of t. I would be 2 cents short. It's not a big deal if you're just talking about $2,000 and $1,867, but I think you get the idea. The larger your sums of money are, when you round down, the shortfall can be quite a few dollars. Just something to think about before you move on to example 3. I do recommend that you pause the video after each example and try and replicate this yourself, and make up other problems or work out other problems if you have access to those. Moving on to example 3, you have deposited $1,000 in a CD, a certificate of deposit, for 4 years. What rate of interest must you earn if you want $1,250 after 4 years? So our unknown here is the rate of interest. And what information do we have in order to solve for that? You have deposited $1,000 today, so that's present value. I'll try and write everything in the same sequence. So rate of interest, of course, is unknown, so I'll have to leave that blank. You have 4 years in hand. What you want, the amount, is $1,250. Now, you can try algebraically rewriting this formula in terms of R. Tends to become a little involved. So since my objective here is to show you how to use Excel to speed up your calculations so that you can focus instead on the analysis, I'm going to show you how to solve for R using Excel. Now, you do not know what the rate is, but your goal is to write a formula like this. Now, how about we put in a starting value for R and we get Excel to solve for the R. So I'm going to start out with, let's say R is, what might it reasonably be with the problems that we have worked out so far? I have been changing time, rate, everything. So maybe I will just work with the 5% since I cannot pick up anything from these examples. I had 3 years, I had 2 years, I had different rates. So I'm going to give it a starting value of 5%. Now with a starting value of 5%, the future value would work out to equals $1,000 times 1 plus this rate to an exponent of this time. So at 5%, I would have, or you would have, $1,215.51. Naturally, then you can reason that your rate of interest would have to be higher in order for you to achieve your financial goal of having $1,250 after 4 years. You can keep doing trial and errors here. So what if I say 5.5%, so 0.055, I'll have $1,238.32. Once you get an idea of this trial and error method, we will hand over this trial and error to Excel. We go into the Data tab, into the What If analysis, and we are going to use Goal Seek. And here is what we are going to do. We are going to tell Excel our goal, and we are going to tell Excel to help us attain that goal by determining a rate of interest. So here's our Goal Seek dialog box, and it asks us what cell do you want to set to what value. I'm going to say this cell here where I calculated the future value. This needs to have a value of $1,250. Excel asks me, what cell would you like me to change in order to achieve that? I tell Excel, please change the rate of interest. And we say OK. And Excel says you need 5.74% approximately, rounding it off to 2 decimal places. Target value is 1250. Excel shows you it was able to get this close, 1249.9999925. This will do for us. So we'll say OK. Important thing to understand, please write your answer. Rates of interest are always quoted as a percent per annum. So when you translate this calculated rate into your answer, please say approximately 5.74%. Let me try and put the approximately symbol here as well. Let me see, I'll do this only if I can find it fast enough. Otherwise, you know what the approximation symbol looks like. Please make sure you put that. Quick check here. Looks like I don't want to waste any more time. So you write approximate when you're writing this answer. In our fourth example, we are going to solve for time. We have solved for the other 3 unknowns. Now it is solving for time that we need to do. You have deposited $1,000 in a CD. Your bank offers you 2.45% interest. How long will it take for your money to grow to $1,500? Well, we have deposited $1,000 now, so that's our present value. Our bank offers us a 2.45% rate, so that's 0.0245%. Divide by 100, which means the decimal moves 2 places to the left. How long will it take? T is unknown, but we do know that we want our money to grow to $1,500. Now again, you can rewrite this formula in terms of T. It does involve the use of natural logs in order to solve, since T is an exponent here. If you have done a calculus 1 or a business calculus, you know how to rewrite this formula in terms of T. I'm going to show you using the same goal seek function that we had done before, how to solve for T. Again, you do not necessarily need a value here, but I like to put a starting value to just get a feel for the numbers, just so it gives a better sense of what Excel is doing in the backdrop. I am going to say maybe it will take us 8 years. Again, we will write a formula for future value. We'll calculate the future value of $1,000 at 2.45 interest rate for 8 years. We may not get 8 as our answer. Very likely we won't. We'll get Excel to then do our trial and error and help us attain our goal. So equals, here is the present value times 1 plus, here is the rate of interest to an exponent of starting value of T. We have $1,113.66. It will take us many more years to get to $1,500. I can raise this to 10 years or 12 years to see the effect. We'll need more than that. Let's get Excel involved. Data, what if analysis, goal seek. We want this cell to have a value of $1,500, and this time we want time to be changed. And Excel says you need a little more than 16 3/4 of a year. Again, when you write your answer, please say approximately 16.75 years. And that's our introduction to how to use Excel, how to write formulas, how to take help from Excel to solve for unknowns, the 4 different unknowns in a compound interest formula.